Imagine drilling a hole straight through the earth, from one side to the other. What would happen if you jumped in? Would you fall endlessly or reach the other side? Would you fall straight through and come out the other side? Or would something else happen? It's a question that sparks curiosity and leads to fascinating scientific insights, pushing the boundaries of our understanding. In reality, drilling a hole through the earth is currently impossible due to technological limitations. The Earth's core is made of molten iron and nickel, reaching temperatures hotter than the surface of the sun, making it extremely hostile. Even if we could withstand the heat, the pressure at that depth would be unimaginable, crushing anything that dared to venture there no matter how strong. But for the sake of exploration and imagination, let's consider we could overcome these challenges with advanced technology. What would we encounter on this hypothetical journey to the center of the Earth? Strange landscapes, unknown materials, and perhaps even new forms of life? If we drilled a hole through the Earth and jumped in, we wouldn't simply pop out the other side. Instead, we would embark on a fascinating journey through the planet's core. We would fall towards the center of the Earth, accelerating due to gravity, gaining speed as we descended deeper and deeper. As we fell, the mass of the Earth above us would start to pull us back upwards, slowing our descent. This counteracting force is due to the gravitational pull from the Earth's mass. This hypothetical tunnel, often called a gravity train, is a thought experiment in physics. It explores the intriguing dynamics of gravity and motion within a massive object. It demonstrates how gravity changes as you move through a massive object like the Earth, with gravitational forces shifting as you pass through different layers. The journey wouldn't be a straight shot, it would be more like a pendulum swing, oscillating back and forth through the center of the Earth. This oscillation is due to the interplay of gravitational forces. However, this back and forth motion wouldn't continue forever. Over time, other factors come into play. Air resistance within the tunnel would slow us down with each pass, eventually causing us to come to a halt at the Earth's center. This resistance would dissipate our energy, bringing our motion to a gradual stop. Drilling through the Earth, even with hypothetical technology, presents a monumental challenge. The Earth's crust, the outermost layer, is already several kilometers thick. Below the crust lies the mantle, a region of hot, dense rock that extends for almost 3,000 kilometers. Even if we could overcome the heat and pressure, keeping the hole open would be a near impossible feat. The immense pressure from the surrounding rock and magma would constantly try to collapse the hole. It would be like trying to drill a hole through a swimming pool with a straw. The water would simply rush back in and fill the space. Section 4. The shifting pull of gravity. As we descend into the Earth, gravity doesn't disappear, but its pull changes. At the surface, we experience the full force of Earth's gravity pulling us downwards. However, as we move towards the center, the mass of the Earth above us starts to counteract the pull of the mass below. At the very center of the Earth, we would experience zero gravity. This is because the mass of the Earth would be equally distributed around us, pulling us equally in all directions, effectively canceling out the gravitational force. Section 5. Falling through the Earth. If we were to jump into our hypothetical hole, which stretches from one side of the Earth to the other, we would accelerate continuously as we fell towards the center, pulled by the force of gravity. Our speed would keep increasing until we reached the very center of the Earth, where it would be at its maximum velocity. After passing the center, we would begin to slow down, because the gravitational pull would reverse, now pulling us back towards the center from the other side. We would continue to oscillate back and forth like a pendulum, our speed decreasing with each pass due to air resistance and friction. Eventually, we would come to a standstill at the center of the Earth, trapped in a state of weightlessness, unable to move in any direction. Of course, this is all theoretical, assuming we could survive the extreme heat, immense pressure, and lack of oxygen on this incredible journey through the Earth's core. Section 6. Back to reality and some fun facts. While drilling a hole through the Earth remains a fantasy, the thought experiment allows us to explore complex physics concepts in an engaging way. It highlights the nature of gravity and how it behaves as we move through a massive object. The deepest hole ever dug by humans is the Kola Super Deep Borehole in Russia, reaching a depth of about 12 kilometers. While impressive, this is just a fraction of the Earth's radius. which is over 6,000 kilometers. So, while a journey through the Earth remains a scientific impossibility for now, it continues to inspire our imagination and fuel our curiosity about the world beneath our feet.